everyone, welcome to this video. And in this video, we're going to discuss perimeter and area in the coordinate plane. Let's have now a definition of perimeter. A perimeter is the total distance around the polygon. So when you have a curve, we call that as circumference. However, in some other literature, they call it like perimeter as one. Okay? As long as it's a closed figure, we're working on that. Another definition that we want to look at is the area. It is the total square units inside the polygon or what it contains in a closed figure in a two-dimensional aspect. Let's have an example. I have here a triangle, which is a right triangle. Now, as you can see, this is a right triangle. So you have one leg that is 3, another leg is 4, and this is the hypotenuse, which is 5. Now, when you talk about perimeter, you add all the sides. So when perimeter, adding all sides, 3 plus 4 plus 5, that would be 12 units. Now, when you talk about the area of the right triangle, you multiply the legs and then divide by 2. So area would be 1/2 length times width. So your leg would be 4 as the length and then width is 3. So multiplying 4 times 3, that would be 12 divided by 2. That would be 6 square units. Because this is two-dimensional, so square units. However, how about this one? It's one dimension. That would be 12 units as a unit of measurement. If it's not given a unit of measurement, we use now units. Okay? Let's have now another example. This is a quadrilateral. Assuming a parallelogram. So 7, 7, 5, and 5, you add all the sides. So we will get now the perimeter. So this is a parallelogram. So 2 times the length and width because you have the two, twice the length and then twice the width. So 7 plus 5, that will be 12. Then times 2 will be 24 units. Now when it comes to the area of parallelogram, that's length times width. So 7 times 5, that will be equal to 35 square units. Okay, let's have now a distance and let's have now the perimeter and area in this manner in the Cartesian coordinate plane. Now, as you can see, I have 3 points, point A, B, C, E. So where the coordinates are for point A is 6, 3, where point B is 3, 3, and point C is 3, 7. Now, you need to find out the distance of this one. However, as upon looking at it, you can now use in Geogebra. It's for you to easily work there. There are two methods on how to look at it. First is that you can work on with their coordinates. So for example, if I want to find out the distance from AB, you type now point A and B. It will give you now the distance. Another, if you want to find now the distance from B to C, you have now 4. And another is that you can have now find the distance from A to C. That would be 5. So I have now the distance. However, another method to look at, so let me just delete this one. Another method for you to highly visualize that is to put a segment. So remember you have points. So from point A to point B, B to C, and then C to A. Now you go back to the algebra tab. You'll have now the distance as defined as FGH. Now, to find out the perimeter, you know that the segment AB, segment BC, segment CA, you can put now an input like for F plus G plus H. And that is now your perimeter. Okay? You can add now that this is now a perimeter. Going back, so working with that. Once again, I want to go F plus G plus H. And this is now your perimeter. Now, how to get now the area? Remember, you have now your horizontal distance, which is this one, the AB, and then the vertical distance. Now, remember, this is a right triangle. So, a right triangle will be divided by 2. Now, get now your F and G, multiply that, FG, and then divide that by 2. So, the area now is 6. So, that is now how easy now to find now an area and perimeter using now GeoGebra and in the Cartesian coordinate plane. Okay, let's have another example. Now, in this case, I have now 4 points defined by this one. So you can put that on a setting that name and value. So that's 4, 3. Now let's go with this one. Once again, in the setting, name and value. So everything would be put in name and value. Okay. Now looking at that, so you have now your value that is negative 4, 3, 5, 3, negative 7, negative 2, 2, negative 2. Now, I want to find now the perimeter and the area. So I'm going to go with the tool to look at now that. So I want to put now a segment from A to B, B to D, A to C, and then C to D. Now, upon looking on that, let me go back to algebra. Now, I'm going to have now all my details. F would be the measurement of AB. G would be the measurement of BD. AC, and then CD. Let's see. Let's have an experiment. AB plus BD. Let's see. Oh, it's working. And then we have now CD, another technique, and then plus AC. So I have now 29.66. Are you able to see that? So that is now the perimeter now of the quadrilateral form in the Cartesian plane. Now let's have another one. So we want to find now the area. So this is a parallelogram. Now a parallelogram, so multiplying now the length and width. So I have now AC times AB. So multiplying that, so I have now 52.48 as the area. That's it. I hope you learned something about the perimeter and area in the coordinate plane. So you need to explore that using Geogebra. That will be a great help for you to visualize and expedite the process on how to solve the perimeter and area of a closed figure in a coordinate plane. Hope you learned something with this video. Have a great day, everyone.